Hello friends, in today's class we are learning about applications of equilibrium constant. Equilibrium constant means either Kc or Kp. There are three different applications for equilibrium constant. The first application is to predict the extent of a reaction. Okay, to predict the extent of a reaction. If the value of Kc or Kp is greater than 10 raised to 3, then the product predominates. Which means if Kc is very large, the reaction proceeds nearly to completion. That's the first point. To predict the extent of reaction, if the value of K is greater than 10 raised to 3, then product predominates. What do you mean by product predominates? That is, the reaction proceeds nearly to completion. Similarly, if the value of Kc or Kp is less than 10 raised to minus 3, then the reactants predominates over the products. That is, if Kc or Kp is very small, then the reaction proceeds rarely. Okay, so this is that first application of equilibrium constant. Depending upon the value of magnitude of equilibrium constant, we can predict the extent of reaction. If the value of Kc is greater than 10 raised to minus 3, if the value of Kc is greater than 10 raised to 3, product predominates. That means if Kc is very large, then the reaction proceeds nearly to completion. Then if the value of Kc is smaller than 10 raised to minus 3, then reactant predominates over products. That is, Kc, if it is very small, then the reaction proceeds very rarely. Okay, suppose the value of Kc, if the value of Kc is in between 10 raised to minus 3 and 10 raised to 3, then then we can say that both reactants and products are present at equilibrium. If the value of Kc is between 10 raised to minus 3 and 10 raised to 3, then we can say that the reaction is in equilibrium. That means both the reactants and products will be there. So the first application is very simple. If you know the value of equilibrium constant, then we can explain that extent of a reaction. Okay, this is the first application of equilibrium constant. Okay, second application is that to predict the direction of a reaction, either forward direction or backward reaction, we can predict that direction of a chemical reaction using the equilibrium constant. To predict the direction of a reaction, we are introducing a new term, and that is known as reaction quotient QC. To explain the direction of a chemical reaction, we are introducing a new term, that is reaction quotient QC, and it is the ratio of molar concentration or partial pressures of the product species to that of reactants at any stage other than equilibrium state. So the calculation part is the same thing what we have done in the case of equilibrium constant Kc or Kp. Only the difference is that if the reaction is in equilibrium, then we are taking the ratio between the concentration or partial pressures of the product towards that of reactant. Then we can call it as Kc, equilibrium constant. In any stage other than equilibrium, if you are doing the same calculation, then that product is known as, then the value is known as reaction quotient. I hope it's clear. So we have given a general reaction AA plus BB reversibly gives CC plus DD. In that one, QC can be calculated just like Kc. Then what is the difference between Kc and QC? Kc is the equilibrium constant, whereas QC is reaction quotient. Okay, to predict the direction, we have introduced a new term QC, and QC is equal to, we can calculate just like equilibrium constant Kc itself. Then if you are calculating, if the reaction is in equilibrium and you are taking that ratio between the concentration or partial pressures, it will be equilibrium constant, otherwise it will be reaction quotient. Then what's the inference that you are getting from that reaction quotient? If QC is equal to Kc, if the value of the QC is equal to Kc, then we can say that the reaction is in equilibrium. Okay, if QC value is equal to the value of Kc, then we can say that the reaction is in equilibrium. If QC is greater than Kc, then we can say backward reaction will be taking place, and if it is smaller than Kc, forward reaction will be taking place. Okay, so this is the information inference that you are getting from the reaction quotient. We are comparing the magnitude of both reaction quotient as well as equilibrium constant. If both are equal, then we can say that the reaction is in equilibrium. If QC is greater than KC, we can say that backward reaction will be taking place. If QC is smaller than KC, then forward reaction will be taking place. So for numerical, they will be asking, they will be giving some concentration, and they will be asking which direction the reaction will take place. So the KC value or KP value they will be giving in the question. We will have to find out the value of QC and check whether which is greater. Okay, so depending upon the magnitude of both QC and KC, we can say that whether the reaction will be taking place either backward or forward reaction. If the value of QC is greater than KC, backward, otherwise it will be forward reaction. If both the magnitude of both that QC and KC are equal, then we can say that the reaction is in equilibrium. That is an important point. So we have to do some numerical problems. In that one, we'll be calculating the value of QC, only that much. Okay. So we are having an in-text question 7.6. The value of Kp for the reaction, we can say that 2A reversibly gives B plus C is given 2 into 10 raised to minus 3. At a given time, the composition mixture of is given. Molar concentration of A is equal to molar concentration of B is equal to molar concentration of C, which is equal to 3 into 10 raised to minus 4 molar. In which direction the reaction will proceed? So what we will do, we'll be calculating the value of QC. Okay, we will be giving the value of QC. So what is QC? That molar product of molar concentration of the products divided by that of the reactants. Okay, so we will be writing that equation B into C divided by A to the power 2, because stoichiometric coefficient for the reactant A is 2, so you can give as a power. Okay, and we are calculating the value, and they got the value QC is equal to 1, and if QC value is greater than KC, then we can say that backward reaction. In this question, there's a typing mistake is there. The value of Kp, it's not value of Kp, it's value of Kc. Its value of Kc is given. Okay, so read that question properly. The value of Kc for the reaction is given. So what you will do, you will be finding out the value of Qc. The same thing what we have studied in the case of equilibrium constant. We are calculating that ratio. The value is equal to 1 here, that is greater than Kc. Then the backward reaction will be taking. Okay, so we are having one homework exercise question number 7.12. A mixture of 1.57 moles of dinitrogen, 1.92 moles of dihydrogen and 8.13 moles of ammonia are introduced into a 20-liter reaction vessel at 500 Kelvin. At this temperature, Kc for the reaction is equal to 1.7 10 raised to 2. Is the reaction mixture at equilibrium? If not, what is the direction of the net reaction? So what you have to do, you will have to calculate the value of QC, and if the value of QC is equal to KC, which is given in the question, if it is equal, we can say that the reaction is in equilibrium. If the value is greater than Kc, then we will be saying that the backward reaction will be taking place. But the concentration is not given in this question. Instead of that, the number of moles is given. Okay, so we know that concentration is equal to number of moles divided by volume of the solution, so that we can say that. Okay, so instead of that, molarity is not given, concentration is not given, only the number of moles is given. So you'll have to find out the molarity or that concentration first. How will you find out? A number of moles divided by volume. Volume is given as 20 liters. You have to substitute that one directly into the question, so that you will be getting for dinitrogen, for hydrogen, for ammonia, the concentration will be getting. That values you are supposed to submit or substitute in the equation QC and find out the value of QC. If QC is greater than Kc, then we can say that backward. Just check. Okay, do it as a homework. Okay, that was the second application. So first application was to predict the extent of a reaction. Second one, to know about the direction of a chemical reaction. The third application of equilibrium constant is to calculate the equilibrium concentration. To calculate the equilibrium concentration, for that we are following the rules. The first rule is write a balanced chemical equation. Write the balanced chemical equation regarding the reaction. Then second one, under the equation, note down the initial concentration and equilibrium concentration or its partial pressures in terms of X. Substitute in the equation of equilibrium constant and solve the value for x. Okay, so this is that method that we are supposed to follow to find out the equilibrium concentration. What is the steps? You have to find out, you have to write down the balanced chemical equation. Under the chemical equation, we will have to note down the initial concentration as well as equilibrium concentration in terms of x. Okay, these values you can substitute in the equation for that equilibrium constant, then find out the value of x. From the value of x, you will be getting that equilibrium concentration. Very simple one. To calculate the equilibrium concentration, we are supposed to use that rules which is given in the slide. Okay, very simple one. Either you can give that information regarding in terms of concentration or in terms of partial pressure. So we will be doing some numerical so that it will be very clear to you. Okay, so now we have an exercise question 7.9. It's exercise question 7.9. I will be reading the question. Nitric oxide reacts with bromine and gives nitrosyl bromide NOBr as reaction is given when 0.087 mole of NO and 0.0437 mole of Br2 is mixed in a closed container at a constant temperature. 0.0518 moles of NOBr is formed at equilibrium. Calculate the equilibrium concentration of NO and Br2. So in this question, they are asking equilibrium concentration of the either reactants and products. Whatever it is, we are supposed to use that equilibrium constant. That means third application of equilibrium constant to predict or to calculate the equilibrium concentration. Okay, so in that what you are supposed to do, the first step, as I said, write down the balanced chemical equation. It is given already in the question, or else you are supposed to write 2NO plus Br2 reversibly gives 2NOBr. Under the equation, we are writing initial concentration in terms of number of moles. In this question, they have given number of moles. So you are supposed to do like that only in terms of number of moles. You are not supposed to find out the mass of the substance. Okay, you directly write down initial concentration as in terms of number of moles. Under NO, we can write down 0.087, which is given in the question. Similarly, in the case of Br2, it will be okay, that of Br2 will be equal to 0.0437. Okay, initially, as we know, the reaction to NOBr is not given because initially there will not be any products. So that has to be written as 0 SH. That is very important. If we are writing the initial number of moles, that means before the reaction starts, there will not be any product. So we can write down initial concentration 0.087 moles in the case of NO, Br2 is 0.0437. That is given in the question. Both terms are given in the question. NOBr, which is not given, that has to be written 0 SH because before reaction there will not be any product. So that will be taken as 0. Under that equilibrium concentration, we are supposed to write down in terms of X. X means that amount of substance that decreased when the reaction starts at a particular time interval. How much amount will be of the reactants will be decreased. That decrease can be represented as X, and 0 in the case of 2NO molecule, equilibrium constant is equal to 0.087 minus 2x. Why we have taken 2x there? The stoichiometric coefficient is 2, so that 2x you have to write down. Equilibrium constant 0.087 minus 2x. In the case of Br2, there is no stoichiometric coefficient. So what we'll write 0.0437 minus x itself. There is no stoichiometric coefficient. So 2x, 3x, we don't want any numbers like that. Simply you'll have to write down 0.0437 minus x. Then NOBr. NOBr is taken as 2x. Product will be taken as 2x. Again, the stoichiometric coefficient in that case also will be equal to 2. So you are supposed to take 2x. Okay, and in the question we can say that the value of NOBr, number of moles of NOBr is taken as one value, and at equilibrium. They clearly mentioned that the reaction is in equilibrium. Okay, so that is also you'll have to note down that equilibrium constant. At equilibrium, the constant, the value of NOBr is given, that will be equal to 2x itself. So it is given that 2x is equal to 0.0518. So x can be calculated. If you are substituting that value of x in that equilibrium constant, that is equilibrium concentration of 2NO is taken as 0.087 minus 2x. In that value, if you are x, you are substituting for x, the value which is obtained from that equation 2x is equal to 0.0518. Then you will be getting the equilibrium concentration of NO. Similarly, if you are substituting next term, Next term means 0.0437 minus x. If you are substituting the value of x there, you will be getting the value, the concentration of Br2. Similarly, already the value of NOBr is given, so we are not supposed to calculate that one. Okay, so this is the third application. Using this one, so many numericals are given in the textbook. So once again, what is that procedure that we are supposed to use is that write down the balanced chemical equation under that initial concentration, which will be given. Almost all problems they will be given in terms of number of moles or concentration. With this number of moles is given, you can directly substitute like that only. No need to convert into mass. Okay, but one thing is product. The amount of product initially it will be equal to 0, so you are supposed to write down 0 there. Okay, then second term is equilibrium concentration. Okay, in terms of equilibrium constant, when we write equilibrium concentration, a value has to be x has to be subtracted. What is x stands for? The decrease in concentration or partial pressure of the reactants. So when we are subtracting, you keep in mind, if any stoichiometric coefficient while writing the balanced chemical equation, that also has to be multiplied with x. So in the first case of NO, you are supposed to subtract 2x from 0.087. In the case of Br2, since there is no stoichiometric coefficient which is equal to 1, so that you can directly write down 0.0437 minus. Okay, like that. And equilibrium concentration of product is given as 2x as such. From that you can find out the value of x and substitute that equations, simple equation, so that you will be getting the equilibrium concentration of the reactants as well as the product. Okay, so you have to do the problem by yourself, then only it will be clear to you. Okay, so we are having next problem. Now we are having another problem, that is in text question number 7.6. The value of Kp for the reaction is given at that is 3 at 1000 Kelvin if initially the partial pressure of carbon dioxide and partial pressure of carbon monoxide is given, and equilibrium partial pressure. Calculate the equilibrium partial pressures of carbon monoxide and carbon dioxide. The previous question in terms of concentration it was. Here that the same question, equilibrium concentration in terms of partial pressure they're asking. That means equilibrium partial pressure we have to calculate. So as I said that write down the balanced chemical equation, carbon dioxide plus carbon, which is reversibly given, that 2 CO molecule, and what you have to write down in here, initial instead of initial concentration you are supposed to write initial pressure. Initial pressure is given 0.48. A carbon solid ayukonde we are not supposed to write down the partial pressure of the carbon since it is a solid substance. Next you have to write down partial pressure carbon monoxide is equal to 0, because before the reaction starts there will not be any product, as I said, so that will be taken as 0. Under that you can write down equilibrium pressure. So as I said before, you have to subtract a value x here also. Here 0.048 minus x, in the product it will be 2x, because the stoichiometric coefficient in the case of carbon monoxide is equal to 2, so that also has to be written 2x. Then write the expression for Kp, so that the value, since the value is given for Kp is given, we have to write down the expression for Kp, substitute that values, so that you will be getting the value of x, and substitute again equilibrium pressure condition, that means 0.48 minus x and 2x. So the important point is that to find out the value of x, for that we are supposed to use what any one method that you have learned in standard 10. The solution of a quadratic equation, whatever it is, you have to solve the value of x any method, using any method, and substitute in that equation, so that you will be getting value of x. Okay, so that value of finding of the value of x is very important. After finding the value of x, you are substitute about in the equation equilibrium pressure or equilibrium concentration. So the previous question we have given that value of Kc, so that equilibrium concentration has to be taken here in terms of partial pressure. So these two problems, one is solved in the question, another one which is given in the exercise question, you are supposed to do again in your notebook and find out the answer by yourself. Okay, I think the method is clear. So using this technique, you have to find out the equilibrium concentration or equilibrium partial pressures of the different reaction. In that exercise, that means at the end of the this chapter, so many questions are given related to this topic. Okay, so I will be giving some homeworks also. That homework has to be done in your notebook before the next class. Okay. So today I am giving more homeworks for you. The homeworks which is given in the slide, Question in text question 7.4, the value of Kc at 800 Kelvin for the reaction is given. Calculate the equilibrium concentration of CO2, water, H2O and carbon monoxide at 800 Kelvin if only carbon monoxide and H2O are present initially as 0.1 molar each. So as I said, write down the chemical equation. Under that initial concentration is given. The 0.1 molar concentration, both the carbon monoxide and water initially it will be equal to 0.1. Under the product, what we can say, the product will be always 0, 0. Carbon dioxide also, before the reaction starts, there will not be any products. So that will be taken as 0, 0. Then after that, equilibrium concentration. So initial concentration minus some value in terms of X. So there is no stoichiometric coefficient in the equation. Before that, just take once again whether the reaction is balanced or not. Okay, before writing we have to check once again the reaction which is given in the question is balanced or not. If it is balanced, let's take the stoichiometric coefficient. So in this question I think it's balanced. If it is there, you have to do. Okay, appo the concentration will be equilibrium concentration taken as 0.1 molar minus X for both the carbon monoxide and water. Like that you can continue and find out the value of X. Okay, Kc is given. Write down the expression for Kc. From that you will be getting some values of X. And using that value of X, you will be getting that equilibrium concentration. Write down the expression for Kc. Kc means molar concentration of water into molar concentration of hydrogen divided by that of, like that we have learned that equations, that terms in terms of X can be substituted in the equation for Kc or Kp. In this question it is Kc, so you can substitute in that one, so that you will be getting the answer. Okay, that is in text question 7.4 that you can do as a homework. Similarly, next question, 13.8 grams of N2O4 was placed in a 1 liter vessel. The same question itself, in terms here that Kp, in terms of Kp you will have to find out, calculate Kp and Kc and partial pressure at equilibrium. Try to solve that one. If you are having any confusion, you just ask me. Okay, the same type problem itself. Then one more problem I'm giving in text question 7.9, the 3 mole of PCl5 kept in, that is in text question. That also, that whatever it is, calculate the composition of the mixture at equilibrium. So the same method can be. So you have to read the textbook thoroughly once again and find out the answers by yourself. Okay, so many homeworks I am giving again. Exercise questions. Exercise question 7.8, 7.16, 7.15, 7.17, 7.19, 7.20. All these questions you have to do as homework. Okay, so try to do 2 problems in each day so that it will be finishing within 1 week. Okay, if you are doing more and more problem, that will be very helpful for you to finish that such problems during exams. Okay, so at least try to do 2 numericals per day to finish that homeworks. Okay, I know that number of homeworks is a little bit more, but you are supposed to do as homeworks, try to do 2 problems per day. Okay, so that it will be easy to finish. Okay, so that was the 3 applications of equilibrium constant to predict the extent of the reaction, to find out the direction of the reaction, and to calculate the equilibrium concentration of or partial pressures of different species, either reactants or product. So using the second and third application, we will have so many numericals also. We try to finish it off, that one on time, and learn properly. Okay, that's very important. Questions, numerical questions will be there for your exam also. Try to finish it off on time. Okay, study well. The next topic is that relationship between equilibrium constant, Q, reaction quotient, and Gibbs free energy. What is that? The relationship between Gibbs energy, equilibrium constant, reaction quotient, and Gibbs free energy. We have learned what is Gibbs free energy in the chapter number 6, thermodynamics. Equilibrium constant, we have learned this chapter, equilibrium constant also. So what's the inference that you are getting is that if delta G is negative, then the reaction proceeds in forward direction. If it is positive, it proceeds in backward direction. If delta G value is equal to 0, then the reaction is achieved equilibrium, and the formula, mathematical representation for that is equal to delta G is equal to delta G0 plus RT ln Q, where delta G is Gibbs energy, delta G0 is a standard Gibbs energy, R is a universal gas constant, T is the temperature, Q is the reaction quotient. Okay, or at equilibrium we can write down standard Gibbs energy delta G0 is equal to minus RT ln K. K stands for the equilibrium constant either in terms of Kc or in terms of partial pressure Kp. Okay, so delta G0 is equal to minus RT ln K. That formula you will have to learn. You have learned already this formula in chapter number 6 thermodynamics. You have to use that formulas also to find out the values. Okay, so using this one we are supposed to do some numericals. Question number in text question 7.10, the value of delta G0 for the phosphorylation of glucose in glycolysis is 13.18 kilojoules per mole. Find the value of Kc at 298 Kelvin. The formula is related with delta G0 is equal to minus RT ln K. R value we know that 8.314. Then Kc they are asking delta G0 is given 13.8 kilojoules per mole. We know the kilojoules is not a standard unit for us, so that has to be converted into joules per mole by multiplying it with 10 raised to 3. This is direct substitution, nothing else. However, you have to find out the value of Kc. Similarly, one more question number 7.11, hydrolysis of sucrose gives 1 molecule of glucose and fructose. Equilibrium constant Kc is given and calculate delta G0 value. The same type question is a direct question. So here also the direct substitution, the formula is basic formula is delta G0 minus equal to minus RT ln Kc. Find out ln means logarithm, RT everything, all the data is given, temperature is given, R value we know, Kc value is given, direct substitution, only that much. Find out the value for delta G0. Try to solve that problem in your notebook and show me when the school reopens. Okay, so today we have learned so many things. One is application of equilibrium constant, 3 different application with numericals. So many homeworks I have given. Next one is the relationship between K, Q and Gibbs free energy. Try to solve all this one, and if you are having any doubts you can ask me. Okay, thank you so much for watching this video. Study well and try to achieve more marks in the coming exams. Thank you. Okay, if you are having any doubts you can raise it now, or personally you can ask me. Thank you.